quiz tomorrow and homework check due. But yesterday, I did a bunch of worksheet 4 with you. And today I'm pretty much going to do all of worksheet 5 with you, which are 2 of the 3 assignments that are due on the homework check. So unless you were playing solitaire on your phone all day yesterday, then you probably are partway done with the homework check. Okay. I'm also going to go over what's on the quiz today. So please have out worksheet 5 and whatever it says up there. Okay. Okay. I'll look at it. Otherwise, yeah, I just want to make sure we get through all the quiz review stuff. Okay. Okay. Oh, happy birthday. Remind me at the end of class. I have cupcakes, but only for you. Because I have them for math team. All right, guys. You have 30 seconds to do these 3 questions. Go. I have other staplers over here. Don't worry about it. I'll worry about it later. Worksheet 5. The old stuff. It isn't? Okay, guys. What's going on here? Cosine times. So we get any confusion? What about this one? Everybody okay? You all right? Yeah. Okay, this is actually straight up on your blue sheet. It actually says 1 over secant is cosine. Otherwise, I know some of you wrote out 1 over cosine, which is 1 divided by 1 over cosine, which is 1 times cosine over 1, which is cosine. Okay, moving on. What do you want to try on 4? Okay, we can take out a cosine, or we could divide each one by cosine. You'll get exactly the same answer. Whoa. Half power messed up. That should be a 1, right? What can we do then? The cosine out here can cancel because it's multiplied. It has nothing glued to it with a plus or minus. And a 1 minus cosine squared. Now, nowhere on my sheet does it say 1 minus cosine squared. But it says sine squared plus cosine squared equals 1. And if I move this over here, it'll say minus cosine squared. So therefore, this can be traded for a sine squared. Everybody okay? I will review the exact kind of problems we have for simplifying on the quiz if we get that far, okay? What about this one? Okay. Sine squared plus cosine squared is, so then I have 1 plus cotangent squared over cosecant. 1 plus cotangent squared is exactly on your sheet, right? Cosecant squared. So what's a cosecant squared divided by a cosecant? Questions? All right, this section is not on the quiz, so we're just going to review this quickly because then you'll have it done for the homework check. Sound like a plan? Okay. Which are the even functions that have y-axis symmetry? And its reciprocal, which is, okay. The even functions that have y-axis symmetry allow you to take the negative and just get rid of it, because going left and going right will give you exactly the same answer. The odd function, all the rest of them, you get the opposite sign if you go left or right. So when you have a negative inside, you move it out front, okay? Move it out front for the odd functions, drop the negative if it's even. All right, so quickly, what would we do on number 6? It's odd, so we do what? So it's negative sine of 2x, and that's all you have to do. Number 7, taking each piece individually. Cosine is even, so what happens? I drop it and just becomes cosine of x. Secant, right, is also even, so we drop it. Yeah, and we end up with cosine times 1 over cosine, which is 1. Number 8, cosecant is the reciprocal of sine, so we have to do what with the negative? Negative cosecant of 5x. These are not on the quiz tomorrow. They're not on any quiz, at least for a while, that I remember. Okay, tangent, even or odd? Odd, so we move it out front. And back here, sine is odd, it moves out front. But cosine is even, so it goes away. And a sine over a cosine is a tangent, and we keep the negative. Did I really confuse anybody there? Like I said, it's not on the quiz, but I can go back over something if you have a question. All right, this is also not on the quiz. These are actually graphing questions. You're to graph this in y1 and this in y2, and then answer either yes or no. Are they the same? That's it. Anybody know if number 11 would be the same? This is an amplitude stretch, and this is a period change. Are those going to be the same graph? No. Think about 13 for a minute and make a prediction. I'm going to skip 12. You guys can try typing that in. But on 13, 1 minus sine squared could trade for a just a cosine squared, and then it has a square root. So does it seem like it should be equal to cosine? If you graph this, 1 minus sine squared, see how I typed that all in? With a big square root, and then a cosine is in my y2. They're not the same. Can anybody tell why? Yeah, cosine has negative values, and sine squared, once you square it, will only have positive values. So this is a no. This one in the middle was a yes? Did you try it? Did you? Oh, you did the identity rather, yeah. I would have probably done the same thing because it's a pain to type in. She just proved it rather than typing it in. All right, going on. These are on the quiz. What do you need to solve these? Your blue unit circle. I am looking for where the cosine is 1/2. So I'm looking for an ordered pair that has a positive 1/2 as x, which would occur at okay, am I done? No. As a matter of fact, I've kind of messed up. Didn't leave myself space because the directions say negative infinity to infinity, all values, no restrictions, so it can go on forever and ever and ever. So I need to put what on the end? Okay. And it really, guys, should say plus or minus 2 pi n, not just 2 pi, okay? I should be making you right, but I'm not going to. N is any integer. Okay. Number 15. There's no cosecant on my unit circle. We need to stand on our head. This is 1 over the sine equals negative 2 over 1. If we stand on our head, that will say the sine of x equals 1 over negative 2. Is there that? A negative 1/2 for the sine on our... Okay. 11 pi over 6 and you could call that one negative pi over 6. It's the same as 11 pi over 6. And then because it's sine, we're still adding 2 pi. If you're confused, please ask, because I'm sure you're not the only one. Everybody all right on that one? Okay. The hardest ones to me are tangent, because they're not on the unit circle. We have to be careful because there is a 3 up here, so we have to divide by 3 first. So then we have the tangent is negative square root of 3 over 3. Here are my hints, guys. It's got to have a 3. Okay? So there are ordered pairs around my unit circle that look like this. And there are ordered pairs around my unit circle that look like this. Those both have a 3, right? On these, if I put the y over the x, do you remember that the denominator cancels out? 5th period, they still want to fight me about that. Are we good that when you flip 1 over, the 2's would cancel? So you put the y over the x, you just here would get square root of 3. Is that what we were looking for? No, so this ordered pair didn't work. But here, if I put 1 over square root of 3, I would get square root of 3 over 3. So the only thing I need is I need one of these to be negative and one to be positive, or this one to be positive and this one to be negative. Can you find those 2 spots? Yeah, is it 5 pi over 6, guys? Okay. What do you notice when you write those down or when you're looking at the unit circle? They're directly across from each other. Why is that? A tangent graph has a period of pi. So you could put just pi n and just put one of them. That would be fine. If you put both of them, you can either put plus 2 pi n or plus 1 pi n. I don't care. Like I told the class earlier today, if it said t minus 2 times t minus 2 equals 0, and you told me t equals 2 or t equals 2, would I count that wrong? Just because you listed the answer twice, okay? This and this line up. They're the same. You're just listing an answer twice. I'm okay with that. All right. What can we do on 14? 2 times tangent times cosine minus square root of 2 times tangent equals 0. Yeah, you got to get used to factoring these guys. Lots of them will factor. Take a 2 out, or tangent, sorry. So we're dividing that out. Left will be 2 cosine of x minus square root of 2. Now, we don't really need to do any crazy like squaring or anything because we have 2 things that multiply to make 0. So either this one is 0 or this one is 0. Then what? I can look at this one in a second. What do I need to do? Some algebra over here, right? Add square root of 2 and divide by 2. Everybody okay? Do I need to show that or you got it? Okay. Tangent again. Tangent is our downfall. Tangent is a y over the x. When will that be 0? At those two places, yes? Y over x, y over x. So those were, look up here. This one says only 0 to 2 pi. And it says to call that 0, but not 2 pi, right? So what did we want to write for these two answers? 0 and pi. No plus or minuses. Why? As it said to stop at 2 pi. And so we're just looking for square root of 2 over 2 and for a cosine 2 places, and they would be at because it's got to be positive, right? Everybody understand why it was only the 4 answers and not any plus or minuses and all that kind of stuff? All right. This one wants us to do degrees, and that when we get to that part, it won't be hard. How do we start out, though, solving this? Add the 1, divide by 3, okay? So we have tangent squared equals 1/3. Then we need to square root, okay? When we square root something with an x, we need to be careful to remember plus or minus. The square root of 1 is 1, but in the denominator we have a square root of 3. Now, that simplifies, but it's actually kind of nice. This is a y over an x. Isn't that exactly what we're looking for? The y over the x without rationalizing it? Okay. Now, we have a plus or minus. So basically, any of those can be positive or negative, right? So how many places is that going to be? 4. Because I could have positive square root of 3 over 2, 1/2, negative square root of 3 over 2, 1/2, positive square root of 3 over 2, negative 1/2, negative square root of 3 over 2, negative 1/2. Okay, I'm not sure I said that right, but I need all 4 of those, but what do I want in? I need them in degrees because it, for some reason, it did degrees. Okay. Now they are, no, there aren't any that are in degrees. It's not hard because you just need, but the first one was at 30, right? And then aren't they at all the same places on your little bow tie? So it was 30, 150, 210, and 330. Everybody okay? The degree part wasn't hard. It was just remembering it wanted degrees, but nice. Already factored. I set each of those equal to 0. What will I get? Cosine of x is 1/2. Tangent of x is 1. Okay. This one's easy. I'm just looking for the ordered pairs with a positive 1/2. Pi over 3 and 5 pi over 3. Okay. Am I done with that one? Negative infinity to infinity means, yeah. Okay. This is the one that some students struggle with. For the tangent to be 1, it would be great if I could do this, right? 1 over 1 is 1. That's beautiful. That's not on my unit circle. Okay. Yeah, it's got to be someplace that the y and the x are equal because y over x has to be 1. So these have to be the same. So we're looking for either square root of 2 over 2 or negative square root of 2 over 2 and negative square root of 2 over 2. And what do you notice when you find those two things? They're across from each other because it's a tangent graph. So you could just tell me pi over 4 plus or minus pi n. Again, if you wrote pi over 4 plus or minus 2 pi n and 5 pi over 4 plus or minus 2 pi n, did I get that one right, guys? I wouldn't count it wrong, okay? But you really only need one, and you really should be doing pi because that's the tangent. But this actually does cover them all, so. Any questions? All right. On this question, C and D, the idea of angular and linear velocity, are on the quiz. There is not a modeling question where you have to come up with an equation from a word problem this time. I do have a whole worksheet of them for you to do over the weekend. Don't shoot me. Okay. Now, it says Rudolph's riding a Ferris wheel. His highest position is 60 feet. His lowest position is 8 feet. 2 revolutions every minute. At 10 seconds in, he's at his highest. Okay. I'm kind of going fast because it's not on the quiz, but it says it takes goes around twice in a minute. How long does it take to go around once then? Twice in 60 seconds, so once in 30 seconds. Yeah, we're just going with it. So this was 30 seconds to get to the end. So this would be 40. I really need the 30 though, right? Because the 30 is the what? Period. Okay. All right. Some of you are struggling with the difference between vertical shift and amplitude. What you need to realize is that the amplitude is how far above and below the midline. And the midline is called the midline for a reason because it's exactly in the middle. To find the exact middle, you average. So 60 plus 8, 68 divided by 2, the midline is at 34. Okay? If you subtract, that's a distance of 52. Cut in half is 26 above and below that. Or you could just go 34 minus 8 is 26. Now, which of those numbers is the amplitude? 26. One other thing some of you keep trying to do is you want to move this back so that you don't have a phase shift. You want to say, well, I can move it back and then it'll be whatever. It doesn't move back nicely and there's no reason to. Just go for this was a distance of 30. If I go 30 this way, it doesn't go back until finish a period going this way until, okay, who cares? Use your shift to the right 10 and then it's a plain old cosine, yes? Okay, so y equals amplitude, 26, cosine because it started at a max, right? Okay, yeah, this is not the b, right? It's 2 pi over 30, which I'm actually going to leave just so that you remember where it came from. It should reduce, but it's fine, pi over 15. T minus 10 because we shifted it to the right 10. And the vertical shift goes on the back, which is the midline. Not on the quiz. Okay, find the height at 20 seconds. You just need to put a 20 in here. You can do it on the home screen. You don't have to graph it. It does come out 21 feet. I'm just moving on, okay? You would need to be in radians. Angular and linear velocity. I'm going to put a quick slide in here and review real fast. Angular velocity is radians per time. It just has to be radians per time, if I could spell. Okay, radians per time. That's it. Once you have radians per time, we're good, unless it specified a kind of time you had to have. Linear velocity, yeah, it's kind of a funny V. It's a Greek letter. But the formula is angular velocity times radius, okay? And then you will have a distance per time. Does this all sound familiar? Okay, so all we got to do for angular velocity here It's going around 2 revolutions in a minute right now. Is that what it says right there perfectly? 2 revolutions per minute. I need it in radians and we're done. 1 revolution is 2 pi. I now have 4 pi radians per minute as the revolutions canceled, and I'm done. It didn't say what kind of label. Minutes is fine with me. So if I tell you something's spinning at 600 RPMs tomorrow to find the angular velocity, all you do is multiply by 2 pi and you're done. All right, the linear velocity you then have to multiply by the radius. Okay, this is not on there, so I'm going to go kind of quick, but if his height went from 60 down to 58, or to 8, sorry, what's the radius? The diameter is the distance, 52, so the radius is, the amplitude is 26. Okay, 26 times 4 is 104, I think, pi feet per minute, because magically what happens? The radians disappear. You think? Yeah, it would be fun. Okay. All right. I'm not going to do number 18 because we went over number 18 previously. I hope you did it. If you didn't, find somebody who did if you get stuck. You may take a picture of this if you want, but this is a list of what's on the quiz. You need to know law of sines, law of cosines, area of triangles. The 2 formulas you need are on the reference sheet. Do you remember where those are on the reference sheet? Inverse trig functions, and you can use your colored unit circle. Simplifying identities and verifying identities, and you can use your blue reference sheet. Solving equations, not any with like U substitution like we talked about yesterday. No, not happening, okay? Easy ones, like we did today, where you have to factor out a sign, or where it clearly just says the cosine equals -1/2 and you're done, okay? And there's one where you have to write an equation. It is not actually given a graph. I'll show you in a minute what it says. It says like the amplitude is this, the period is this, the shift is this, what's the equation? That's it. No picture even. Yes. Yes. I'm going to start with these 3 down here. It says find the sine of an angle. That's what that means. Find the sine, or find an angle, sorry, find an angle whose sine is this, but then find its cotangent. I really don't care about the angle, okay? So this is saying draw, or to me it's saying anyway, draw a triangle, sine is opposite over hypotenuse, so I'm going to put an X here and a 3 here. Does that make sense so far, Miranda? Okay, now to find cotangent, I need opposite and adjacent. So I have to do some crazy Pythagorean theorem. If I know legs squared plus legs squared equals hypotenuse squared, I'd have this. If I subtract the x squared over there, it would say legs squared equals 9 minus x squared. To get rid of the squared, I'd square root. And you cannot simplify that. So this is square root of 9 minus x squared. I can show you with numbers why you can't simplify, but for now, can you just take my word for it? The cotangent is not opposite over adjacent, it's adjacent over opposite. So this answer would be square root of 9 minus x squared over x. And the directions for that problem will say, write an expression or something, okay? It's not going to say just solve. This is a straight up, go to your colored unit circle, find where the sine is -1/2. Now, that happens down here in this fourth quadrant, or over here. We need this answer, but we can't call it 11 pi over 6 because remember the restricted domain was -pi/2 to pi/2. So we had to call it -pi/6. you can use your colored unit circle, which is already renumbered with those negatives. Everybody okay? This is another draw. If I draw and have, sorry, that's supposed to be a right angle, an opposite over adjacent of 1/7. If I do Pythagorean theorem, I do 7 squared plus 1 squared, which is 50. The square root of 50, some of you are still struggling with simplifying. What perfect square divides into 50? Okay, 25 and 2, square root of 25 is 5. So this is 5 square roots of 2. And it wants the sine. Sine is opposite over hypotenuse. Ugh, gotta rationalize. I get square root of 2. Square root of 2 times square root of 2 is 2 times 5 is 10. Did I do something wrong? Okay, can you simplify that? No, this guy's in jail, this guy's not. They can't divide out. Okay. Does anybody need to take a picture with the answers done? Are we good? What does D say? Oh, you would graph the line y equals negative whatever and find, does it say negative 300? Oh, gotcha. So does it, are you safe though? You would graph it said above that you're safe at negative 300. So you would graph it and find the first two positive places that it crosses. I don't care if you skip it. Okay. Do I need to talk more about angular and linear velocity? We only have 12 minutes and I want to get to some simplifying again. So I can talk more about this if this is a struggle. Yes? To change this to an angular velocity, you just multiply by 2 pi and you'd have 240 pi radians per minute. Okay? That's the answer for the angular velocity. To find the linear velocity, you have to take that and multiply it by the radius. The radius is what? Okay, so we're going to multiply it by 8 centimeters. Now, it says in meters per second. The one on the quiz makes you do a little, it's not metrics, but it makes you do a little bit of unit conversion. 1 minute is 60 seconds. 100 centimeters, 1 meter. Like I said, I don't think on the quiz it's metrics. Okay, minutes cancel, centimeters cancel. I multiply all those numbers on the top. I multiply these numbers on the bottom. It's 6,000, and this is 6,000 and something. Did anybody type it yet? It turns out to be almost exactly 1. Did you multiply the pi in? You didn't multiply the pi in yet, that's why. So if you type 240 times pi times 8, you get like 6031.9. You divide it and you get roughly 1 meter per second. I don't know how I made up numbers and it came out 1 meter. Any questions? Okay. You have to know area of triangles. For example, given this situation, 2 sides and an angle in between, you'd want to use that 1/2 AB sine C area. Yep. Given all 3 sides, you'd probably use the semi-perimeter formula, and that's all on the blue sheet. Do I need to go over either one of those? Okay. Now, what I did for the 9 minutes that are left, I actually took the retake version of the quiz, changed the numbers, and I have the quiz questions. I do not want you to take pictures, please. There's a couple slides I might let you, but right now, what I want you to just look real fast and tell me if you need me to talk about any of these. We only have 7 minutes, and I think the last ones, the simplifying, getting common denominator, are probably where you want me to hit. But I'd like to give you the chance to read through these questions quick. The first two you would draw. Those seem okay? The first one is the inverse one. The second one is more just a draw and figure out which quadrant you need to be in. Then there's an angular velocity, okay? Then there's a linear velocity. I don't know if there's one where you actually have to factor, but if we factored and divided out the 3, this would be a pi over 3. So the phase shift would be left pi over 3. This is like a law of sines question. Find the arctangent. That's just using your inverse unit circle. This is drawing again. This is solving, but you just got to take out a sign. Well, like this one tells you what quadrant because you go by the ordered pair. The one back here was a little bit tricky. You knew the cosine was positive and the sine was negative. So you have to use that information in your all students take calculus to figure it out, okay? This is solving all solutions. This one I think is a law of cosines question. Just draw your picture and figure out whether you need to use law of sines and cosines. Yep. You'd look at your unit circle and you'd say the sine is negative 1/2 at 4 pi over 3 and 5 pi over 3 and plus or minus 2 pi n. Yep, just solving. Okay, this one is find the area of a triangle given 3 sides. We kind of talked about that. Use those crazy formulas. This one is law of cosines, find an angle. So you got something like 9 squared equals 7 squared plus 5 squared minus 2 times 7 times 5 times cosine of s. And you got to work backwards. 2, I don't think so. Okay. All right, I'm going to the simplifying. First, this one is one where you just plug the numbers in. Can anybody tell me this one? Okay. This is where everybody gets wrong. Do you just put a 4 pi over 7 in? Yes, that's the period. So B is 2 pi divided by 4 pi over 7, or 2 pi times 7 over 4 pi. Remember, you got to flip it over. The pi's cancel. You get 14 over 4 or 7 halves. We okay? It says go to the right because it's positive, so I'm going to put it in as a minus. Vertical shift. Everybody okay? It's all plug and chug except for the period. And don't forget parentheses. All right. This one's pretty simple. Negative, a sine. What's a cosecant? Sine squared. What's a 1 minus cosine squared? Another sine squared. Cosine over sine. I lost a theta here and there. Now what? Sine squared, sine squared, sine, sine. Okay. This one is not that easy. You do have to FOIL it out. You get a middle term. That's what everybody forgets. I'm going to lose my... Okay. I get a sine squared minus 2 sine cosine plus cosine squared minus 1. Sine squared plus cosine squared is what? So then I have 1 minus 2 sine cosine, which should just be this. And I don't know that it's exact, that question. I think there's one where you have to remember to FOIL, okay? I think. Maybe not. Might be just hard because it was on the retake. All right, those are more equation solving. I'm going to skip those. And these are the two I was worried about, okay? Yes. What? Go. Okay, guys, right here, this is simplifying. It's verifying, so you can only work with one side. This is cosine, and this is one I'll let you take a picture of if you want. Cotangent is cosine over sine plus sine. Okay, so right now I have cosine squared over sine plus sine. I need to get a common denominator. Everybody okay with that? So I'm going to multiply this by sine over sine. It's a verify, so please show some work. I get cosine squared plus sine squared, and it was all over the same common denominator of sine. That is 1, and 1 over sine is cosecant. That one was pretty straightforward once you realized you needed a common denominator. This one is also a common denominator. I don't know if both of them on the quiz are, but less fun. What does this one need to be multiplied by? 1 minus sine over 1 minus sine. This one needs to multiply by 1 plus sine over 1 plus sine. Okay, on top I get 1 minus sine plus a 1 plus sine all over, I'm going to show it as 1 plus sine times 1 minus sine. Okay, what does the top simplify to? 2. What does the bottom FOIL together to become? Right, because the middle term drops out. 1 minus sine squared is cosine squared, so I have 2 over cosine squared, which is the same as 2 times 1 over cosine squared, and I really don't care if you skip that step, which is 2 secant squared of x, which is equal to the right-hand side. Okay, you may take a picture of that one if you want. Was there something I got a minute and a half left, was there something you wanted me to go back and do? Okay, if you want to stay because you wanted to practice some of those other ones, I can put them back up, okay? Anybody wants to stay after?